afternoon, everybody. Hi. As usual, my name is Jacob Strecker. I'm Director of Development here at the Cedars, and we're excited to bring forth this April version of First Friday's MC at the Cedars, which is McPherson College. All right, well, I'm going to bring up Steve again, and Steve Gustafson with McPherson College is going to introduce our speaker. I want to thank everybody. This is probably one of our largest groups. I don't know if it's because we're on this side of the banquet facility or that side, but it's great to have everybody here, and we're looking forward to this presentation. Steve?
Thank you, Jacob. I understand there's something called left brain and right brain, so we're on the right-hand side or left-hand side, depending on how you look at things this afternoon. Good afternoon, and welcome to our First Friday at the Cedars. Our presenter this afternoon is Dr. Jonathan Frye, a 20-year natural science professor. Jonathan is our current faculty chair, chair of the Natural Science Division, and the originator of the Center for Science and Religion at McPherson College. He is a graduate of Lebanon Valley College and holds Master of Science and Doctor of Philosophy degrees from the University of Virginia. Dr. Frye's students report that he is a teacher with high standards, expecting academic rigor while also being supportive and fair. His students have gone on to assume positions of leadership in the field of science. Without further ado, let's introduce this afternoon's teacher, Jonathan Frye.
I was asked if I would be willing to come and visit with you all about some topic on a First Friday morning sometime next spring, when I was asked earlier. And I agreed, because I'm an agreeable sort of person, and I came up with a topic without, it didn't take too long, but the title of the presentation in any case is Science, Fact, Fiction, and Futurology. I think I made that word up or found it along the roadside. I'm not sure it's a real word. I want to start with a quiz. Dr. Gustafson said, I have high academic standards and all. So we'll have a little quiz here right at the start. Can anyone identify the gentleman in the picture here? I'll give you a hint. First, some historical context. His birth and death dates there, 1828 to 1905.
That was before my time.
Yeah, I was counting on that being, mostly true here. So I'll tell you who he is. This is Jules Verne. Now, how many of you have read a book by Jules Verne, perhaps sometime in your life? Yeah, so he was arguably one of the first science fiction authors. And he wrote a bunch of books, some of which you may have read, Around the World in 80 Days, 20,000 Leagues Under the Sea, The City in the Sahara is the one there, not as familiar, From the Earth to the Moon, Journey to the Center of the Earth, The Mysterious Island. And these were all written in the 1800s. Now, he had a talent for identifying things that were sort of technologically possible, but sort of beyond the scope of the science of his day, and then writing fiction, around that. So you think of some of these stories. The first science fiction movie was a silent film made in 1902 by a French filmmaker here, and it's a short, silent movie enactment of part of Jules Verne's book, From the Earth to the Moon. And here you see they're loading this giant bullet into the end of the giant barrel of a giant gun that is going to shoot that bullet to the moon with people inside. Now, we know that's not how it ended up happening, but Verne had things correct, like you need to be going 25,000 miles an hour to break free from the Earth's gravity and get to the moon. The escape velocity, the science of the trajectory of shooting something to the moon. He had that right. and that it would be helpful if the launch occurred somewhere close to the equator, because the Earth is spinning around and the equator is already going 1,000 miles an hour, and that gives you a head start on achieving escape velocity. And all of the space launches have been from as far south as we can muster in the US. I mean, that's the reason, that they launch out of Florida and not out of upstate New York, is the science that Verne had right in the 1800s. Another of his books, which was also made into a silent film in the 1900s there, by the same director, and this is beloved Captain Nemo, experiencing the undersea world in his 20,000 Leagues Under the Sea. Okay, another quiz. Another author, another science fiction author. Anyone recognize this fella? Authors usually aren't as familiar faces as the book titles. This is Herbert George Wells, H.G. Wells. So lived a bit later than Jules Verne, but they were alive, overlapped for a while in their lives. And H.G. Wells wrote some books like The Invisible Man, in which he describes a coating on the person that changes the refractive index of their skin to equal the refractive index of air, so that light is not bent or reflected by the person, but passes straight through them and makes them invisible. And the science is right. The technology for doing it, that doesn't exist, although there are folks developing something that works pretty much like that today. So it's on the cutting edge, even though it was written the better part of 100 years ago. The Time Machine, travel in time, which is theoretically possible, and physicists working out how that, bending space and time and traveling through wormholes. The technology is different than he imagined, but the idea is not completely out of the realm of possibility. The Island of Dr. Moreau, on which Dr. Moreau is creating chimeras, organisms that are part one animal and part another animal. It's kind of like genetic engineering. You come up with plants that have bacterial genes in them today. The War of the Worlds, we're probably not at risk of being invaded from Mars, but we're looking for life on Mars and may have found it, or that the conditions are ripe for life there. And one of his later books, written in the early 1930s, The Shape of Things to Come. And in 1933, he predicted that World War II would break out in 1940, which, is pretty close, and a bunch of other things as well. But the idea that these authors take the science of their day and then sort of extrapolate a little bit and think about what tomorrow might bring. This hand-colored lithographic print was made in France in 1882, and the title of it in French, I won't butcher the French, I'm better with German, but the English translation is Leaving the Opera in the Year 2000, from 1882. And you see down below here is the river Seine going through Paris, and the Eiffel Tower, and the bridges there, and the restaurants and the folks who are traveling around are flying. The taxi cabs are flying taxi cabs. The bus here is a flying bus. 1882, looking ahead to the year 2000. The Jetsons, produced by Hanna-Barbera Productions in 1962, was looking ahead to the year 2062, in case you missed that detail in your cartoon watching back in the 1960s, but the Jetsons lived in Orbit City in the year 2062. And so apparently personal flying cars are we keep projecting that out to 100 years in the future, always. I have just two more science fiction authors, and then we'll get to some discussion here. This fella, Russian-born author Isaac Asimov, and he was an incredibly prolific author, wrote 200 and some books on all sorts of topics. Many of them science fiction, but some of them just kind of straight science things, and you have, Isaac Asimov's Guide to the Bible, as well as Encyclopedia of Science and Technology, and then a whole bunch of fiction. One of his many books is a collection of short stories, the I, Robot stories, and some of these have been made into movies more recently. The idea of a mechanical thing with a synthetic brain that was able to get up and move around by itself and could learn about the world, and it's really fictional for 1952 or something when this was published. It's not so far out in the future today. And then this stately looking gentleman, anyone know who that is? This is Arthur C. Clarke, Sir Arthur Charles Clarke. He passed away just a few years ago in 2008. And of these science fiction writers, he's the most recent, but also I think the most perceptive about the science and the predictions that he made. One of his many books, written back in the early 1960s, before we had gone to the moon, was 2001: A Space Odyssey. And what the technology of space travel would be like, the possibility of having a computer that could learn and would have a personality, and things could go wrong with the computer, and just lots of interesting sort of ethical, moral situations come up in this book, and a good bit of prediction there. Now, this is a quote from Arthur C. Clarke. From, I think, the 1970s. I think he was being interviewed by the BBC in 1974, I believe, when he said this. But when a distinguished but elderly scientist states that something is possible, he's almost certainly right. When he says that something is impossible, he's very probably wrong. And the only way to discover what the limits of the possible are, is to venture a little past them into the impossible. And science is about, sort of pushing those limits. And it's doing it right up to today. The end of this quote from Arthur C. Clarke is that any sufficiently advanced technology is indistinguishable from magic. And really, this was the starting point for my idea for this talk, was that last line. Because you all, except Katie, or mostly, have lived through most of the 20th century, and you've seen changes in the world, and particularly in technological advances, that are just outside the realm of the rest of human history and human experience. And if you can put yourself back into your childhood understanding of how the world works and how things around you work, and then you look at the technology of this wireless microphone that has my voice bouncing around and coming out of the ceiling, or the handheld battery-powered laser in my hand, it's magic. If I could take this back to 1930, it's magic. Dick Tracy, you know? And he had that wristwatch thing that he could, well, you know, you can go buy one now. You know, the iWatch. It connects to your iPhone and your iPad, and you can walk along, yes, you can be out for a jog, you know, and receive emails and talk to people anywhere in the world and send pictures and sound files. You can listen to music that's being streamed in from a satellite in space and being broadcast from someone in Sri Lanka.
Ask everyone here how many of them knew about this.
How many of you, well, the question is, how many of you knew that these are now available? This is a brand new sort of thing. Oh, it's about a quarter of the group. Yeah, okay. So, I mean, my grandfather was born 1911, and horse and buggy on his farm. They later got, you know, a tractor, but that wasn't until the 1940s. He bred draft horses for the local Amish farmers. Okay, so Percherons and Belgians were the two breeds that he specialized in, and that was the way farming was done and the way the world worked. And that's the way it had worked in the 20th century up to that point, the 19th, 18th, 17th, you know, it's like long back out of memory, that's how people had farmed. That's all changed. You know, telecommunications, so much has changed recently. So what I wanted to do to get this to be more of a discussion, my lecture part is just about over. Yeah? This is the last slide. Is to introduce a few fields of science that seem to be areas of particularly fast change and rapid development currently, and then get your thoughts on two things. One is predictions that were made early in your life and how they have or have not come true during your lifetime. And if you turn then and look forward, what do you predict is going to be the magic that someone's going to come and talk to me about, you know, 30 or so years from now when I'm here at the Cedars? Okay? So the few fields of science that I'd lift up as areas of really rapid change, genetics is one. And just as a real quick recap, you know, 1954, we figured out what the structure of DNA was, that it's a spiral molecule. In the 1970s, we figured out how it encodes information, so what the genetic code is. In the 1990s, they started a project to sequence the human genome. And humans, each one of you has 3 billion little bits of information in every one of your cells. And they're trying to figure out exactly what the chemical structure is, what the sequence of information is for those 3 billion bits of information. When they started that project, they figured it would take 20 years and cost about $20 billion. That was 1990. In 2000, they completed the sequence in half the time they originally thought for about half the cost. It cost about $10 billion. And now you can get your own genome sequenced, not in 10 years, but in a couple of weeks for just a few $1,000s. And with the cost coming down that rapidly, you know, the possibilities of every person getting their genotype and then having medicines that are tailor-made to you, you know, that kind of thing is on the drawing board for scientists. And then the ability to move genes around from one organism to another, or to find defective genes and repair them and replace them. So the whole genetic engineering thing, I think, will be big in the 21st century. A second field is in material science, and particularly nanomaterials, really small things. So scientists are getting increasingly skillful at making very intricate, very tiny things, or materials that have very specialized properties. So making like carbon fiber reinforced stuff, these tiny little fibers, thinner than a human hair but stronger than steel, and then you can make big structures out of them that are really strong but very lightweight. That kind of stuff in material science. Information technology, the ongoing computer revolution. About every 18 months, computers become twice as fast and have twice as big a memory as they did 18 months before. And the costs keep going down. So now I'm an old professor, and Dr. Gustafson had said I've been there 20 years. And before I left the University of Virginia, I bought a computer to write my doctoral dissertation on. I spent $2,000 on the computer in 1991. And it had a 100 megabyte hard drive, and I really went for the gusto, you know. This past Christmas, I gave my son a thing the size of a deck of cards that's a removable hard drive to attach to his computer that holds 1.5 terabytes. And I had to even look up how many thousand times bigger than my old computer it was. So a terabyte is 1,000 gigabytes, and a gigabyte is 1,000 megabytes. You know, it was 1,000,000 times the computer storage capacity, and it cost $100, not $2,000. If I had wanted to purchase that much computer power in 1991, it would have cost me 1,000,000 times the $2,000 I spent, which would have been $2 billion. Now I got it for 100. You know, project that forward just a few years, and it's magic, you know. And throughout our lifetimes, from my grandfather's childhood when it was mostly firewood, you know, but most of the 20th century was fueled by fossil fuels. And we're all accustomed to cars, and we put gasoline in the tanks. It's not going to be the same 100 years from now. I don't know that we'll be flying like the Jetsons, but we will not be using fossil fuel powered internal combustion engines. What will we be using? You know, how will we provide the energy that it takes to do the things that people do, and how will that affect the environment is kind of a big question for the 20th century. Now, science has really excelled, particularly in the past 100 years, at generating lots of information about how the world works. We have more and more and more data. There are satellites orbiting overhead, and they're, you know, photographing and scanning, and there's just all that genetic information. There is not thousands or millions, but there's billions of times more data points now than there were when you were a child. But the sort of question here is, you know, so you have all this increase of data, and that leads to what? Does it lead to an increase in wisdom? Or does it lead to an increase in stupefaction? And I thought of that word when I was preparing this slide, and then I thought, I better go to the dictionary and check and make sure that this really does say what I intended to say. And stupefaction has two definitions in the dictionary. One is a sense of amazement. You're stupefied, and meaning just amazed or wowed by stuff. And the other is you are made stupid, okay? You're overwhelmed, and you just can't cope. And so is all of what science is giving us leading to people that are increasingly wise about how to live in the world, or people that are increasingly stupefied, overwhelmed? I teach a couple of classes in the sciences that are really ethics classes. And so I have a couple of the last two quotes in the bottom here. Anyone know the source of this quote? With great power comes great responsibility. Say it, Katie. Spider-Man. Stan Lee, comic book author. Spider-Man says, or Spider-Man's father, Peter Parker's father, gives him this bit of advice because he's gotten the powers of the Spider-Man at this point. In the original cartoons, when the world was all concerned about radioactivity, the kid becomes Spider-Man because he's bitten by a radioactive spider. In the more recent movies, he's bitten by a genetically engineered spider. And that's what gives him the powers. But in either case, Stan Lee, but he was not the first. Actually, the quote goes back to Voltaire. Of course, he said it in French. Again, I won't inflict any French on you, but this is not a new idea. And in fact, here's another quote, but it's basically the same idea. From the one who has been entrusted with much, much more will be asked or required. Anyone know where that quote comes from? Yes, you're a good audience. Okay. Luke chapter 12, verse 48. So the idea of with great power comes great responsibility. I mean, that is the human predicament, and it has been for a long time. And those science fiction authors that I introduced the talk with all wrestled with that. They're like, oh, what if we had this power? Then, no, we're responsible for how things turn out. How could that be? So they fictionalized accounts of that. Well, so I'd like you to, since you're seated around tables, if you could discuss around your table the sorts of predictions that were made by science fiction types earlier in your life, and pick one per table that has or hasn't come true, and then we'll share from each of the tables. So let's just take 2 or 3 minutes to do that. I'm going to call us back together here, and I'd like to, give you each table an opportunity to share a little something that you talked about. I tried to get around, and I think every table had something different, by the way, when I came to visit you. So and we'll end with you. How's that? I'll come back to you last. So just quickly sharing what was the question at this table was.
Well, I guess we never quite got past it, but what if science keeps doing so much with our DNA and all that, that people, will they get to the point where they never die?
Yeah, can you live forever? Immortality. And can you achieve that through science? And, you think about, over the course of the 20th century, the human life expectancy at birth has increased a lot. Most of the increases come because we've been able to provide clean drinking water and antibiotics. So there's a lot less death due to infectious disease. In the 20th century, we also killed more of one another than in any period of human history before, and we can only hope, to come. But in spite of that, the population in 1900 was about 2 billion, and now it's more than 7 billion. And so the unintended consequence of increasing people's life expectancy is that the population has grown dramatically. If you could make it so that people lived forever, the population would increase even more dramatically, if that's possible. And that's going to cause a whole lot of other problems. Okay, so immortality. What What other, Steve, what came there?
Guess what? We talked about digital photography.
Digital photography.
We're talking about digital photography, and
Thank you, Bob.
and yeah, and how you don't know if a picture's real anymore. It can be enhanced and manipulated.
That's true. It used to be that the only image you had of the world was the one you got through your eyes, you know, and then we developed technologies in the 1800s and since to make, photographic images, which initially people didn't recognize and were afraid of. I know my mom, as a little girl, was afraid to have her picture taken because she thought somehow it was going to flatten her, and that the picture that she'd seen of other people was like part of them pressed on a page, and she didn't want to have that done to her. And there are some folks who would look at a flat picture and not be able to relate it to the three-dimensional world that they're accustomed to. So, and then the fact that they can be doctored and dodged, and now you go to the movies, and much of what you see on film is generated by computers. It never existed. It's not even a digital picture of something. It's just an entire, out of a whole bolt of cloth, digital creation, which are sometimes frightening and sort of hyper-realistic that way. So, next table. The amen corner. Do tell, Anna.
We misbehaved, we're in the corner.
Yeah.
Our question is, will we still have libraries and books, hymnals, Bibles, with the age of digital?
And the answer from the front table is no. I'll say the revolution of movable type printing in the early 1500s, Gutenberg, and that changed society incredibly. And if you think of Martin Luther happening to be alive at that time, and he translates the Bible into German, and then it's able to be printed and distributed, and literacy expands. More and more people are able to read, and they're able to read the Bible themselves, and then able to read all those other things that we print and send around. So, just think of how much stuff has been written and distributed as a result of relatively cheap printing. And now you can distribute stuff on the internet, or digitally, and it goes all over and it gets there a split second later, and most of it is not worth reading. I mean, your book reading list in 1520, there was only one book on it, and it was a pretty good book, And now there's so much that you can't possibly, even read the titles of everything that's printed, and a lot of it maybe not so worthwhile. So, are we getting wiser? Are we being stupefied by the overwhelming amount of material, whether it's print or electronically accessible? So,
Ours kind of revolved around medical science, cloning, replacement parts for the body, mapping of the brain, and what the possibilities are for that. The new $100 million program proposed to map the brain.
yeah,
and
billion, but yes.
Was it billions?
20 billion, I think. Yeah.
Oh, okay.
Yeah. Wow. What's a few billion amongst friends? So
Yeah.
it's,
And we talked about what the driverless cars. We talked about that, and what that so those are some of the things that we talked about. Yeah.
And
yeah, healing of cancer, Alzheimer's, those kinds of things, what the possibilities related to what science.
And if you ask your average scientist, they love difficult questions. I mean, they really thrive on trying to answer difficult questions. If it's easy, why bother? So things like cancer, which is, we were discussing at the front table here, is not just one disease, but it's many, many, many different diseases. So cancer is not going to have one cure, it's going to have many, many cures. The brain is maybe the most complex, structure that science has tried to tackle, to understand. And it's a good question whether a brain is sufficiently complex to understand a brain. That may be a nut that science cannot crack. But the promise that the kind of research holds out, that someone who has cancer will have a cure for their cancer. Well, yeah, I'll put my 2 cents in for that. That someone who has Alzheimer's, they'll find a treatment that can reverse the effects of that. That someone who is in a coma or otherwise unresponsive, there's been a few studies recently where they did that sort of MRI brain imaging of a person who had been in a persistent vegetative state for 10 years. They've been non-responsive for years. And they asked the person questions, and different parts of the brain would light up for yes and no. I mean, they would be able to, the person was able to respond, to hear and respond to the questions, and they could detect that response. And so the thought that, that person is in there, and the technology may provide a way for them to communicate out of that. Well, yes, if that was my wife in the coma, I would want that technology. So it's hard to say no. But these are the same things that lead to, the increases in the human population and the challenges that faces to the rest of the world. It's also true, all this advanced technology stuff is more available to us than to most of the world, because we are the wealthiest folks in the world. And the question of whether, a fairness question, an ethical question about, if you've got $20 billion to spend, should you spend it trying to understand how the brain works, or feeding hungry people, or addressing some more basic human needs of people who are not able to afford the fancy brain research. Pharmaceutical companies in the US spend a lot of money solving problems like how to regrow hair on men's heads, and not so much money curing malaria. Okay. Not to be too pessimistic here. Oh.
Go ahead, you guys. Science teacher here. We all just immediately seemed to think of when the computer was brand new and it took up a whole room. Mm-hmm. And how it has progressed now to
there.
And then we also talked about how amazing it is, how intelligent the children are about these things, learning to read when they're barely out of the crib, and just so many skills that youngsters have. Mm-hmm. My great-grandkids, for instance, could probably help me with almost any computer problem. And they're little.
And I will come back around to the computer thing at the end here, I think. Go ahead.
We also thought about some things that do not turn out. For example, when I was young, we were imagining automobiles being driven by nuclear power, and that has not turned out to be possible.
It's only in the movie Back to the Future. Yes. Where some banana peels and a can of beer, some nuclear reactor. Yes.
We talked more about things that have happened in our lifetimes that are amazing as well. Talked about premature births and those children who weigh 1 pound and 2 ounces are alive and would not have been. We talked about refrigeration, farming, fantastic things in the area of farming that have changed. What else? Oh, I remember growing up, my mother said, someday you'll answer the phone and you'll be able to see that person you're talking to. And how amazing that seemed then, but all those things are happening.
The survival rate for 1 pound infants born 4 months premature is over 50%.
We talked more about the future of energy technology, solar as well as wind, and the problems that we're seeing involved with it, and how long we could live on the fossil fuels.
Yeah, and that was on my short list of things that I see likely to change in the 21st century. Yeah, and it's a complicated problem. So it's the kind of thing that scientists like, but there are some underlying laws of physics that no answer to that question of where are we going to get our energy from are going to break those laws of physics. And so at least science is working within those constraints. And I would say I probably we're more likely to see huge advances in efficiency of energy use as opposed to increasing production of energy. But if the population, doubles again, as it already has in my lifetime, more than doubled, we're going to need either more energy or a lot more efficiency. Okay, and the last table.
I'm not sure I represent our table's discussion, but I raised something to you, and that is, this is all talking about the development of the material world and our involvement in it and our amazement and, if you will, obsession with it, which may interfere with our development in the spiritual world. As this goes up, our interest, we're still willing to kill people in millions, just like they used to kill people in hundreds or thousands, and think nothing of it. I wonder, well, my own belief and my own study, is that there is a spiritual world that we really don't know very much about in relation to what we know about this, and we really don't want to know.
Well, I think that science is not the place to turn for the answer to that question. Scientists have sort of clearly and intentionally in their own minds defined what the subject of science is. And they define it as, we're interested in how the universe works, and the universe is defined as matter and energy as it exists in space and time. And so if it isn't material or energy, then it's not the subject of science, and somebody else can study that.
Space and time seems to be kind of the limit of science, and timeless is this other realm of eternity that we're talking about. But space and time, in my lifetime, from the flight of Lindbergh and his finally kind of degeneration into flock mentality. When we see the birds fly around here in such numbers that just a cloud, it seems that to me that space and time is really about as much as we can think about here and keep our feet on the ground.
Yeah, okay. I did not bring a watch along today, but I borrowed one from Chris. It's 5 minutes to 3, which is, I think, the scheduled ending time for this. And so I want to tell you a science fiction story. I hadn't prepared necessarily to do this, but a couple of the questions reminded me of a particular story by Isaac Asimov, one of the authors they introduced you to. And he wrote a whole collection of stories that had, as a central character in the story, a massive, initially, huge computer. They built this, huge, powerful computer in the near future. The story might have been written in the 1950s, about the year 2000. So, computers that had incredible abilities to calculate stuff and to run cities and systems. And the computer was so large and complicated that it took some people to run it, to maintain it and to feed it data and to ask it questions, and then it would provide answers. And one night, the two workers who were there, working the night shift with the computer, and they've had a drink or two, and they get a little tipsy, and they ask the computer a question. And the question is it possible for entropy to be reversed? Entropy is one of those laws of physics that governs our, anytime you convert energy from one form to another, some of it's converted into waste heat, and the world is going to become more and more disorderly over time, the universe will. And the computer ponders this question and says there is as yet insufficient data for a meaningful answer. And then the story leaps forward in time, a few hundred years, and people are flying around in spaceships, and the computer has gotten more powerful and smaller, and now every spaceship has its own one, and it's only a little thing. It's not as big as a house. And the folks on the spaceship, and they ask the computer the same question hundreds of years later. Is it possible to reverse entropy? And the computer thinks about it for a bit, says there is as yet insufficient data for a meaningful answer. And go much forward further in time, and the computer has become smaller and smaller, and actually most of it is not in space and time anymore. It's kind of in this other dimension. So it's not here in the universe with us, but it's out there in hyperspace someplace. And people again ask the computer the question, and the computer gives the same answer. There's not enough data to give a meaningful answer. And then people have gotten so that they're living forever. And their bodies are just sort of maintained in like suspended animation on the planets, but their minds, their spirits are freely roaming around in space. And the universe as a whole is getting old. Entropy it's running down. It's kind of dying this slow heat death. But the computer is now outside of space and time in this hyperspace, and it has figured out how people could merge their consciousness with the computer off in hyperspace. So all the people are doing this and abandoning their bodies, but their souls, their essences are preserved there in the computer somehow. And the last person, before merging with the computer, asked the computer the same question one last time. Is there any way for all this to be reversed? And the computer says there is as yet insufficient data for a meaningful answer. And the last person goes off and merges with the computer. And the computer's it's done everything in the whole history of the universe except answer this one question. And it's got nothing else to do. And the universe is dead and gone, died this heat death. And so the computer ponders this one last question. Because although there's no more data coming in, it hasn't, tried every possible arrangement of the data, come up with every possible answer. And eventually, after some timeless interval, because there's no space and time left, the computer knows the answer to the question, but there's no one to tell it to. Okay? And so the computer considers this, and it decides that that's okay because the answer will take care of that. Okay? And the computer says, "Let there be light." And that's the end of the story. Isaac Asimov. Okay? Yeah, that's way out in the future, So science fiction, that's fictional, but it does tie together anyway the theme of computers getting smaller and faster, and the idea that science is preoccupied and has preoccupied us with the material world, but maybe the big important questions are not about those things, but they're about other things. And one of the challenges living in the world that we do live in is not to be overly distracted or stupefied by the science. Okay, and I'm really glad that you all invited me here to speak, and we're so willing to engage in conversation, and I'm glad we do this again sometime. It'd be great. So thank you.